Hi folks, Mr. Long here with a screencast on the chain rule. And this is we're starting to get a little more complex in our understanding of the chain rule and the types of chain rule questions that we can answer. This we're going to be doing with general algebraic derivatives. By that I mean, so the derivative of g of x is g prime of x. And we're going to be using those tables, the same tables that we've used the last couple of types of questions we've been doing. And that really, I think that consistency helps. It allows you to understand how to figure out values on that table. So again, I'm not going to have the table in front of me here as I do this. I do think that you should follow along and have that table in front of you though, as you go through this, as you fill in your handout. So again, this idea of general functions can be very confusing. So this right here, g of x, is just some equation, or some relationship. We don't know what it is. We just have data in a table for different values. So we know what g at 1 is, g at 3, g at 5, g at 7, and g at 9. We know the derivatives for all those points too. So g of x is just some relationship. We don't know what the equation is. We only know ordered pairs on the curve and values of the slope for g of x at certain points. So here's the equation that we've been given. Y equals 2 multiplied by g of x to the fourth. In other words, g of x has an exponent of 4 on it. What I did here, you'll notice, is I introduced a set of brackets around g of x. And that, to me, kind of helps isolate out what's happening. So g of x is being raised to the exponent of 4, not the 2. The 2 is just a coefficient out front. So we want to take this equation, and we want to get the derivative when x equals 7 for 2 multiplied by g of x to the fourth. So when we look at this and we do the chain rule, we always have to start with decide what's the inside function and what's the outside function. So in this case, the inside function is just g of x. Well, what's the derivative of g of x? Just g prime of x, right? That's pretty straightforward. But that's kind of, it can be a little bit confusing. And by the way, I'm calling the inside u. So our inside function right here, that is u right there, okay? So let's start going through it. So that's our inside function. So what's the outside function then? Well, the outside function is 2u to the fourth because g of x is u. What's the derivative of that? Well, it's going to be dy by du, and 2 times 4 is 8, u cubed. Okay, 8u cubed. Now to get the overall derivative, I need to multiply du by dx and dy by du together. Now let's make sure though that we're going to get the right result. So du and du cancels out, right? Because that's one on the top and one on the bottom. And that would mean I get dy by dx. Yeah, that's perfect. That's exactly what we want. Y prime, dy by dx. So let's get an equation for it. So I just need to multiply this and this, right? So what I would do is I would multiply the 8's going to come to the front, right? So the 8 multiplied by g prime of x multiplied by u cubed. But again, what is u? U is g of x. Okay, u is g of x, so let's work through that. So we're just getting our general derivative here, y prime. So I've got the 8, g prime of x right here, and then it better be u cubed, right? And in fact it is, right? It's u cubed. So g of x is u cubed. Now I need to substitute in. Can I actually figure out what I want to get y prime at 7. I want to get the tangent slope at 7 for y. So I need to substitute 7 in for x and find g prime. So again, I'm going to go to my table. I look at x equals 7, go down the table until g prime, and so it's g prime at 7. Then I'm going to substitute in g at 7 and cube that answer. Okay, that's not the derivative, that's the y value. Now that's the point where I go to the table. So 8, this 8 becomes this 8. G at 7 on the table is 1. So g prime at 7 is 1. So the tangent slope for g is at 7 is 1. And then I need to get the y value of g of x when x equals 7. And that's 3. And now I need to cube that. Okay, so 3 cubed is 3 times 3 times 3. That's 27. And then I have to multiply that by 8. And that is definitely not 72. It's actually 72 multiplied by 3. That's funny. 72 multiplied by 3. So that's 72 and 72 is 144. Or 7 times 3 is 210. So that's 206. So what I did is I only multiplied by 3 squared, which is 9. Okay, so I did 8 times 9 is 72, but really I had to get another, I had to multiply by another 3, which I think I know why I did that, because I couldn't do that. I couldn't do 27 times 8 in my head, even though I probably should have been able to. So, so that's the process, right? So 7 times 3 is 21, 210, that should be, sorry, 216. Mr. Long. Okay, so I think we see that. So let's double check, or let's go over this next one. So the next one is y equals 4 divided by f at x squared. 4 divided by f at x squared. And we want to figure out the tangent slope if x is 1. Okay, so I'm defining this new function in terms of f at x. So the first thing I want to do is write it with a rational exponent. Like I bring it up to the top, and I use -2. That's going to allow me to use the chain rule, right? Because I have a function inside a function. It looks as though the inside is f at x, and the outside has the 4 and the -2. But we can't be 100% sure, but let's see. So u is the inside function. That's f at x. That makes sense. What's the derivative, du by dx? What is the derivative of f at x? Well, it's just f prime of x. Okay, there's our outside function, y equals 4u to the -2, which makes sense. U is f at x. Then what's the derivative of that going to be? 4 times -2 is 8. Reduce that exponent by 1. Or sorry, there's a negative there too. I missed that negative, but I did write it in, but it's hard to see. So there's actually a negative right there. I'll add that there. So it's -8. -2 times 4 is -8. U, reduce the exponent by 1, -3. Now, I'm probably not going to write it that way. -3, I probably want to write it as -8 divided by u cubed. So if I'm going to do the chain rule, I need to multiply this derivative by this derivative. So again, -8 over u cubed multiplied by f prime at x. Well, that's going to be -8 multiplied by f prime at x divided by u cubed. But what's u worth? U is worth f at x. Let's take a look. So we can see that here, -8 f prime at x divided by x cubed, and then we just change u into f at x. So this right here, folks, is your derivative for y prime. -8 f prime of x divided by f at x cubed. Okay, and I know it's weird working with all these, with the symbols and not actually algebraically getting the derivative. Okay, so let's go through this. So the goal here is to get y prime when x equals 1. And again, y is defined as 4 divided by f at x squared. So what do I need to do? Well, what I need to do is substitute 1 in everywhere, right? So everywhere where I saw an x before, I put in 1, right? So that becomes 1, that becomes 1, and that becomes 1. And now I go to the table that was given, and I find out f prime at 1, and I find out f at 1, the original function value. So I do that, and I start substituting in -8, and f at 1 is f prime at 1 is 1. And then I divide by f at 1 cubed, and f at 1 is worth 3. So that is 3 cubed is 27. So it becomes -8 divided by 27 is our final answer. Okay, so this is important, folks. This stuff here is always on the AP exam every single year. And I would guess this year, again, because you don't have access, or you have access to technology, these are the kinds of questions that test whether or not you understand how to apply the rules conceptually. Okay, so yeah, make sure you've got those down in your notes, and then we'll continue to work through some other questions. There's another type of question, and what I wanted you to notice here is that the inside function was the general function here. Okay, that was the inside function, f of x and g of x. So we're going to do a different style in the next ones.